Okay. Today we're actually going to talk about the real 2-4, which is variables on both sides of the equation. And a couple of things. If you don't know the word identity, I want you to put that in your words to know. So pause the video and put the word identity um, in your words to know and look it up. But obviously, I have a quick little example. M equals M, that's considered an identity. M equals 15 is not an identity. M equals 15 is a solution. But an identity is basically in algebra when you have the exact same thing equal to the left side as you do on the right. Okay? So when you have variables on both sides, what I tell people is you deal with the variables first. So you do not have like terms. 5x and 2x are not like terms. What they are is they're on opposite sides of the equal sign. So what you want to do is you want to bring the smaller variable to the bigger variable. So who's smaller, 5x or 2x? 2x's. So I'm going to subtract 2x from both sides. Now I have 3x. Now I have it as 3x plus 2 equals 14. Okay. So then I'm back to where I was before. So I'm going to subtract 2 here. And when I subtract 2, I get 3x equals 12. And then what do I do next? The next thing I'm going to do is I'm going to divide both sides by 3. And I get x equals 4. I can go now and I can plug this in real quick. I can do 5 times 4 plus 2. And the question is that equal to the same as 2 times 4 plus 14? 5 times 4 is 20 plus 8 is 28. And then over here, 2 times 4 is 8 plus 14. Or that's a plus 2. So that's supposed to be 22. And 8 plus 14 is in fact 22. So I'm good. All right. You have a got it. Pause the video, do the got it, and I'll see you back here in a minute. Now let's look at this word problem. It says it takes a graphic designer 1.5 hours to make a one page of a website. Using new software, the designer can complete the page in 1.25 hours, but it takes 8 hours to learn the software. How many web pages would the designer have to make in order to save time using the new software? So when I'm looking at this, um, I guess what I don't know is the web pages. How many web pages does he need? So I'm gonna web pages would the designer have to, all right? And then I got 8 hours to learn, and I got 1.5 hours to make one page, and I got 1.25 hours and using the new stuff. So I guess what I'm gonna do is I'm gonna say, okay, it takes me 1.5 hours. So if I take, and so 1.5 hours per page. So if I say 1.5p, so if I did like 5 pages, it'd be 5 times 1.5, is the same as the 1.25 hours, right? So 1.25p plus the 8 hours it took to learn the new hardware or software. So on this, which one's bigger, 1.5 or 1.25? Well, 1.25 is the smaller guy. So I'm going to subtract 1.25p from both sides. And then I get, it looks like 0.25p equals 8, right? 0.25p equals 8. And then what I can do now is I can actually divide by 0.25. And then I get p, number of pages I'll have to do is 32. So I'll have to do 32 pages to beyond that, then the new software is better. Okay, so you have a got it. Why don't you pause the video and do your got it, and I'll see you back here in a second for problem number 3. All right, this one's interesting because you have grouping symbols, parentheses. So really the only true way to do this is to dive right in, do 2 times 5x and 2 times negative 1. So 2 times 5x, that's 10x. And 2 times negative 1, that's 2. And then 3 times x, that's 3x. And 3 times 11, that's 33. Okay? And then now we're back to where we were before. Who's bigger, 3x or 10x? Well, 3x is the smaller guy, so I'm going to bring him over. All right? And when I do that, then I now have 7x, bring down that 2, and then this is 33. And then this is just old hat. Now we just add 2 to both sides. And we have 7x equals 35. And then we will divide both sides by 7. And we get x equals 5. You can go ahead and you can plug that in and see if it works. I promise you it will. Why don't you pause the video and try to do the guide it, and I'll be right back with some more challenging stuff. Okay, now these ones, there's 2 problems here. We're going to go ahead and do this like we did the last time. All right. So when we do this, let's go ahead and say, okay, I'm going to do 2 times 5. I'm going to do 2 times 5 and 2 times 6. So here I get 10x plus 12 equals 10x plus 12. Okay. Now, if I just go ahead and I try to solve this, who's bigger, 10x and 10x? Well, they're the same, but I'm going to subtract 10x anyways. And now I get 12 equals 12. I can stop right there. This is what's known as an identity. This means you have infinite solutions. And the reason why I have infinite solutions is because no matter what I plug in for x, it's always going to work. Because 12 is always equal to 12. 12 is always going to be equal to 12. Now this one. Here we have 9m minus 4, but then you have this minus 3m and this plus 12m. I'm going to combine those guys. So I got 9m minus 4 equals 9m plus 5. Which one's bigger, 9m or 9m? They are the same, but I'm going to take and subtract 9m. And then what I have left is I have negative 4 equals 5. Now here the same thing happened. The same thing happened. The m's, the variables, they dropped out. Right? They dropped out. This is not an identity because negative 4 is not equal to 5. So this is just no solution. Okay, so there is a big difference when your variables drop out. When they are the exact same, you get identity. When they are not the exact same, you get no solution. So double check, make sure you know what like terms are. If you don't, put that in the need to know, words to know. Identity, boom. And I think on a scale of 1 to 10, 10 being the best, I'm an 11. Okay, so I hope to see you in class tomorrow, and may the force be with you.